Picture yourself sitting at a campsite in a remote mountain valley hundreds of miles from the nearest city. Your friends back home are streaming movies, working from home offices, and video calling family across the world. Yet you're completely disconnected. Or imagine you're operating a research station in the Arctic, or fishing in the middle of the ocean, or managing a farm in an isolated rural region. For decades, being far from urban centers meant accepting slow, unreliable internet, or no internet at all. But that reality is changing. A technology that once seemed purely science fiction is now becoming commonplace. Starlink, a satellite internet network designed by SpaceX, is broadcasting high-speed internet signals directly from space to anywhere on Earth. The system works even when you're standing in a desert, sailing across open water, or living on a remote mountaintop. And the technology that makes it possible is hiding inside a sleek white dish that looks deceptively simple on the outside. What you see is just the surface. Inside that antenna is some of the most sophisticated communication technology ever designed for consumers. Understanding how it works reveals an incredible engineering achievement. Let's dive in. Before SpaceX ever conceived of Starlink, satellite internet already existed. During the 1990s and 2000s, companies were already transmitting data from space to Earth. But there was a fundamental problem with the existing technology. The satellites used by those earlier systems orbited Earth at an extremely high altitude, roughly 35,000 kilometers above the surface. At such tremendous distances, radio signals had to travel an enormous amount of time to make the round trip. This created what engineers call latency, the delay between when you send a signal and when you receive a response. For most internet activities, this latency was absolutely maddening. Video calls became nearly unwatchable, stuttering and freezing constantly. Online gaming was essentially impossible because the delays made real-time interaction impractical. Even basic web browsing felt sluggish. While the speeds were theoretically acceptable, the delays made the experience frustrating for users. It was clear that the old satellite internet approach had hit a ceiling. Then, in 2015, SpaceX proposed a completely different strategy. Instead of launching a handful of massive satellites positioned far above Earth, SpaceX would launch thousands of smaller, more efficient satellites into what's called low Earth orbit. These satellites would circle the planet only about 550 kilometers up, less than a quarter of the distance of the older systems. By cutting the distance that signals needed to travel, SpaceX could dramatically reduce latency. Suddenly, satellite internet could perform like terrestrial broadband, not like the sluggish system of the past. The vision was ambitious, but SpaceX had a crucial advantage: reusable rockets. The Falcon 9, a rocket designed to land itself and be launched again, made it economically feasible to deploy thousands of satellites. Over the past several years, SpaceX has launched wave after wave of Starlink satellites, creating one of the largest artificial satellite constellations humanity has ever built. There are now thousands of them orbiting overhead at any given moment. But launching satellites is just half the equation. The real innovation happened on the ground, inside the antenna that connects you to this orbiting network. And here's where things get genuinely fascinating. If you've seen a traditional satellite dish, you know what it looks like: a large curved bowl that physically points toward a specific satellite in the sky. The Starlink antenna looks nothing like that. It's much flatter, sleeker, and more modern. That's because it uses a fundamentally different technology, something called a phased array antenna. Instead of having mechanical parts that physically rotate and tilt to aim at satellites, the Starlink dish uses hundreds of tiny antenna elements built directly into its surface. These elements work together as a coordinated system, steering radio waves electronically rather than mechanically. There are no big motors grinding away to turn the dish. The entire aiming process happens electronically, almost instantly. Think of it this way. Imagine you're at a large stadium filled with thousands of people, and they're all doing a coordinated wave. That wave you see ripple across crowds during sporting events. The wave moves in whatever direction people time their movements. If everyone lifts their arms in slightly different patterns, the wave can travel left, right, forward, or backward depending on the timing. The Starlink antenna operates on the same principle, except instead of human arms, it's controlling invisible radio frequencies. By adjusting the timing, the phase, axial of signals from each tiny antenna element, the dish can shape and direct its radio beam electronically. This phased array technology is absolutely revolutionary for satellite internet. As satellites zoom overhead at speeds exceeding 27,000 kilometers per hour, the antenna can instantly track them without any mechanical lag. When one satellite passes out of range, the dish seamlessly switches to the next one. The entire process is so fast and smooth that you won't notice any interruption in your internet service. Inside the antenna, hundreds of these miniature antenna elements are all working in perfect synchronization. Each one receives instructions about exactly when to emit its radio signal. These timing differences, microseconds apart, combine to create a radio beam that points exactly where it needs to. It's a marvel of precision engineering miniaturized into something that fits on a rooftop. When you request a website or start streaming a video, here's what happens. Your request leaves your home router and travels into the Starlink dish. The antenna converts your digital data into radio waves and transmits them upward toward one of the Starlink satellites passing overhead. The satellite receives your signal and either bounces it to another satellite using laser links, yes, lasers in space, or relays it down to a ground station on Earth that's connected to the internet backbone. From there, the information travels across traditional internet infrastructure to reach wherever it needs to go. Your requested data then makes the entire return journey back to your antenna in fractions of a second. All of this happens so rapidly that you experience it as instant internet, with no awareness of the complex relay happening miles above your head. The antenna's intelligence extends far beyond just receiving signals. When you first power on a Starlink dish, something remarkable happens. The antenna begins to move, tilting and rotating as it searches for the best possible view of the sky. This automatic positioning is crucial because, unlike older satellites, Starlink satellites don't stay fixed in one spot. They're constantly orbiting, moving across the sky in predictable patterns. The antenna uses built-in GPS receivers, accelerometers, and sophisticated algorithms to figure out where it is and which direction the satellites are moving. It then positions itself for optimal signal reception. Once it finds its ideal orientation, the phased array system takes over the detailed tracking. But the antenna's capabilities go even further. In snowy climates where the dish might accumulate ice and snow, built-in heating elements can warm the surface. This prevents ice buildup that would block signals, ensuring reliable internet even in harsh winters. It's a simple but effective solution to a real-world problem. One of the most sophisticated aspects of the Starlink system is how it handles the constant handoff between satellites. Because satellites are moving so quickly across the sky, your antenna can only maintain a connection with any single satellite for a limited time before it passes over the horizon. But users don't experience this as a disruption. The system is constantly predicting which satellite will provide the strongest signal next and preparing a seamless handoff. The connection transfers from one satellite to another so smoothly that your video call doesn't even stutter. The satellites themselves are equally impressive engineering achievements. Modern Starlink satellites feature laser communication links, actual lasers that transmit data between satellites in orbit. This means satellites can talk to each other directly without needing ground stations everywhere on Earth. This creates an entire internet network floating in space. capable of routing data across continents through orbit. Information can travel from a remote village in Africa to a fishing boat in the South Pacific almost entirely through space-based infrastructure, never touching the ocean cables beneath. This capability transforms what satellite internet can do for the world. In regions where laying fiber optic cables is impossible or prohibitively expensive, perhaps across oceans, through dense jungles, or over mountains, Starlink provides a solution. Schools in developing countries can suddenly access online educational resources. Hospitals in remote areas can consult with specialists thousands of miles away. Ships at sea can maintain real-time communication with their companies. Disaster zones can be connected to emergency services and information. Communities that were previously disconnected from the digital world now have access to the same internet speeds as people in major cities. As SpaceX continues deploying more satellites and improving the technology, the Starlink antenna will evolve as well. Faster satellites, more sophisticated phased arrays, and improved laser communication systems are all being developed. The trajectory suggests that global internet access could be fundamentally transformed over the coming years. What's truly remarkable is how this technology has been miniaturized and made affordable. A few decades ago, satellite communication required enormous dishes installed by specialists on government and corporate buildings. Now that same capability comes in a device that can sit on your roof or on a boat deck, installed by homeowners without specialized training. The Starlink antenna represents a democratization of global connectivity. Looking forward, imagine a world where internet access is as universal as electricity, where geographic location has virtually no bearing on your connection quality, where students in the most remote regions have access to the same educational opportunities as those in New York or London. That future isn't far away. It's being built right now, one satellite and one antenna at a time. The Starlink antenna is a window into how communication technology will evolve in the coming decades. A technology that beams the internet invisibly through the air, rather than relying on cables buried beneath our feet. Internet that flows through space itself, making our planet more connected than ever before. Thank you for exploring this fascinating technology with us. Be sure to subscribe and let us know what topics you'd like us to explore next. Stay tuned for more stories woven through the smallest details.